My roll number is H5. My topic is network virtualization and resource description in software defined wireless networks. Future network will be defined by software in contrast to a wide network. The software defined wireless network experiences more challenges due to the fast charging wireless channels environment. This article focused on the state of the art of SDWN software defined wireless network architecture, including control plane virtualization strategies and semantic ontology for network resource description. In addition, a novel software developed wireless network architecture with resource description function is proposed along the two ontologies for the resource description of the latest wireless networks. Future research directions of SWN control strategies, designs, and resource description are also addressed. Introduction. It is widely accepted that the future network will be defined by software and an ever increasing demand for broadband communication. New challenges for network keep coming up, such as intelligent and connectivity, efficient and flexible allocation of resource, etc. To meet these challenges, future network must support convergence over traditionally separated network domains and offer great granular and flexibility in control and in data throughput, with the core idea of separating the control and data planes. Software defined networking has been considered as one of promising approach to meet those challenges in future. SDN naturally virtualizes the network architecture and accelerates the data control traffic. The logical centralized control plane with the global knowledge of the network state, is able to obtain, update and even predict the global information. Thus SDN can guide an end user to select the best accessing network or even provide them with the service from multiple network. SDN can be treated as a paradig- paradigm rather than an OSFED architecture where one central software program the control is employed to optimize and dictate the overall network behavior. Software developed wireless network virtualization architecture and OpenFlow SWN by its nature is about making decision on how a connection or a flow is transmitted across the whole network. As mentioned above, the core concept of SDWN is to split the data and control planes. The control plane is responsible for the network resource assignment and decision making. Once the decision is set, it will communicate with the data plane through a particular protocol to finish the transmission. The most widely adopted protocol is OpenFlow. OpenFlow 1 is the first SDN standard and hence the most frequently used SDN language. It is inventor deem it as the enabler of SDN. Not only does it configure the network element, is also provide an open protocol to program the flow table in different switches and routers. SDWN could save the problems of network association efficiently and make both the control plane and data plane programmable. It also helped new technologies to be integrated and tested in network considerable simple and therefore accelerated network evaluation. Architecture design of SDWN. Architecture design of SDWN. Current SDWN research mainly focus on network architecture. Existing designs often focus on different positions in the network. For example, route flow focus on the IP routing service, while FlowVisor and FlowN concentrate on slicing the network physical infrastructure by placing a slicing layer between the data plane and the control plane. OpenRoads was proposed with the intention to replace current Wi-Fi networks. The details of route flow, FlowVisor, and FlowN will now be introduced in this subsection. Route flow consists of two parts: an OpenFlow controller and RouteFlow server running as an application on top of it. There is a virtual network topology with virtual machine where the routing engine is installed on each of them. The virtual network topology mirror the physical network topology. The virtual topology may not be necessarily reflect the exact topology of the real physical infrastructure due to the nature character of SDN, that is to say, according the state of the real-time communication demand, the controller will mirror the actual physical network in different ways. There are three main mapping schemes: 1 is to 1, 1 is to n, and m is to 1 or m is to n, where m and n are both positive integers denoting the number of nodes in physical network topology and logical network topology respectively. These three mapping schemes represent logical split, multiplexing, and aggregation. The virtual network topology mirrors the physical network topology. The virtualized topology may not necessarily reflect the exact topology of the real physical infrastructure due to the nature character of SDN. That is to say, according the state of real-time communication demand, the controller will mirror the actual physical network in different ways. There are three main mapping. Another SDWN control that is built on an OpenFlow called FlowVisor has already been practically implemented since May 2009. It has been deployed into a small network at Stanford University. In this network, FlowVisor acts as a transparent proxy between OpenFlow switches and the other OpenFlow controllers such as NVOX. Within FlowVisor, network resources are sliced in various dimensions by bandwidth topology or a device CPU at etc. It provides much stronger separation between the control and data planes by slicing the network resource into many orthogonal and independent slices through a transparent slicing layer. It enforces block and rewrite control messages as they pass the FlowVisor. A demo of network slicing FlowVisor is shown in figure. Four isolated slices over the same physical network are demonstrated in figure 1. In this slice, two of them are wireless and two are wired. Control strategy. The control strategy could be applied in different layers and different parts of the network architecture. For example, Soft RAN Open RAN concentrated on providing software defined centralized control on radio access network, while RouteFlow tries to execute remote centralized IP routing on computer networks. Odin is a SDN framework based on VLAN and can achieve a virtual access point abstraction on physical switches. Flown is an advanced version of FlowVisor, while OpenRoads is a SDWN application based on FlowVisor. Both Flown and OpenRoad apply software defined on control over physical switches. Details contain the information about the property of data. The RDF is a standard about making statement about the resource. It describes resource in the form of triples, and a triple is a form of subject predicate object expression. A set of triple is a graph. More details can be found in the topology. Information of network can be allocated and updated in a real time from the network. It can be stored in a SQL like database in the form of table in three columns: subject column, predict column, and object column. In semantic web, the ontology is also known as the vocabulary. Although ontology do not have a universal definition to date, to date. In the field of information science and ontology defines a set of class and links between these classes. More specially in network description, the ontology describes a set of nodes and the link between them. It is a body of knowledge describing the network resource domain. The resource domain here is defined by physical entities in networks such as switches, routers, device for competition and storage and the links between them. An ontology describes the network resource with its own layer structure. There are upper level ontology and lower level ontology. Upper level ontology is the fundamental ontology which can be inherited by all sub ontologies. It is technology independent while the lower ontology is a technology specific. Semantic provide a well-designed structure to describe the information for the resource domains and requirement from the client. The main goal of network description language is to make sure that all applications involved in a certain networks have the same understanding of the network architecture, topology, and network resource. Thank you.